All right, so Zach, this is a really good one you just sent me. Are you, I'm gonna go ahead and share my screen here. Are you able to see that?
Yeah, I can
Yes,
see that
I'm
pretty
stuck
good.
on this one too.
Okay, and which number was this again? This is section 9.1 number, do you remember which number it
Uh,
was?
Let me look.
Just
It
so in case.
says number 4 out of 10.
Okay, very cool. So this is number 4. In case anybody's watching this, they can kind of jump into this one. So since an instant replay system for tennis was introduced at a major tournament, men challenged 1,396 referee calls with the result that 413 were overturned. Women 751 with 225. Use a 0.1 significant self-test to claim that men and women have equal success in challenging calls. So the null hypothesis you got correct is that they're equal. The alternative is that they're not equal. So if the verbiage would have said more or less, then that would dictate if it's greater than or less than. Obviously, the online homework gets a little more picky about that. On your exams over this, I don't get super picky on that if you make it one-tailed or two-tailed, okay? Especially when that first time you're doing these. So calculating this z-score, you can use the z-score formula, or we can use StatCrunch. So I'm just going to show how to do this on StatCrunch. Do the find the z-score, p-value, and also the confidence interval. How's that sound?
Sounds good.
So I'm going to go to stat, and these are on proportions, and we actually have 2 samples, and we don't have the raw data, but we have the summary. So are you seeing the correct menu selection here? And I believe there's a video on Blackboard with difference of 2 proportions. I don't know if you've seen that. It's right with the section 9.1 content, but this is pretty much the same as what we're doing here. So I'm gonna hit with summary. So this is where you put the numbers. So let's put the men's numbers first, and that was what? 413 out of 1396. 413, 1396. So that's our P1 hat, our first sample proportion. And then for the women, it was 225 out of 751. 225, 751. Everybody, does that make sense?
Yes.
Okay,
Yep.
and then our null hypothesis. So it looks like it's set up, right? Null hypothesis is that they're equal, the difference is 0, and not equal. So it's a two-tailed test, and all we have to do is hit compute, and there we are. So there's our z-score is negative 0.18. That p-value is 0.8559. If you were to draw a picture of that, that would be, the normal distribution. 0.18 is almost in the middle, right? It's just a little below. So this shows me there's almost no difference between the two. And if you take that p-value, which is it's really about 42.5%, if you double it, you get this 85%. So that's a two-tailed test. That's why the p-value is so large. So when you guys see a p-value of 0.8559, what does that mean to you all? What does that mean that 0.8559 is a p-value?
Is it
So
that
That
it's
would
high?
be
say that again.
the percentages. The percentages are pretty on point with each other.
Yeah, there's probably so the p-value is describing the probability essentially of getting this result by random chance. So we're assuming that they are equal. That's our null hypothesis, and now we actually got some sample data to test that. The sample data, the probability of getting that result by random chance, assuming that they do contest and win at the same proportion, is about an 85% chance. It's a pretty high likelihood. So the data we're observing kind of backs up our null hypothesis. So does that mean we will reject the null hypothesis or fail to reject the null hypothesis? I think I heard a chat. Look over here. Fail to reject is correct, so good job. So we're going to fail to reject the null hypothesis. We do not have significant evidence to reject that they're the same. So that seems to make sense. And the only time we do reject is when this p-value gets low. Now what's low? In this case, they give us a p-value of 0.01. It'd have to be less than a 1% chance for us to reject the claim that they're the same. And really, the p-value method is the way it's done. In fact, the statistics has moved more into saying, you know what, we're not even going to tell you fail or maybe not reject or fail to reject. We're going to say, here's the p-value. Now, what do you think? Is that a rare event? Is that statistically significant? If this p-value was 0.00001, you'd be like, whoa, something's going on here. That's super rare. That should not happen by random chance. Let's tell me there is a difference. And this really is the thinking that's going on when we're doing hypothesis testing. We take a null hypothesis. This is what we believe is going on. We find some sample data. And does it refute that, or does it essentially verify that? And this is what needs to be repeated over and over. For the null hypothesis, or what we think is going on, to change it, it takes a lot of testing. But the null is like we'd call the status quo, what we believe to be true based on experience, or what we will assume to start with. So any questions on how to find this z-score p-value using StatCrunch? You can use the z-score for two proportions formula, but obviously this is a lot quicker. And so any questions on that so far?
No, not for me.
Okay, cool. So how about the confidence interval? So a quick way to do this, instead of retyping everything in, we can just click options, hit edit, and then instead of hypothesis test, we're just going to go with confidence interval. And what level of confidence do we want here? Now this one is a little tricky. So what alpha level did it give us, or what did it say in the question? It said it just tells us right there. That's not so hard. 99% confidence. Sometimes they get a little tricky with the one-tailed, two-tailed thing. For instance, if it was a one-tailed test and it was a 1% alpha level, it might actually be a 98% confidence interval because it's 1% in each tail. Confidence intervals are always two-tailed. And what a confidence interval is just saying, based on our sample data, what are we predicting the true population, in this case, difference in proportions to be? So we can just do that right here. So a confidence interval, I'm just going to change that to 99% confidence and hit compute, and there it is. So we are 99% confident the true difference in proportions of women and men in their ability to overturn tennis calls is between negative 0.057 and positive 0.0495. Well, since 0 is in there, it's definitely possible that there is no difference. So this really verifies that our sample data backs up the idea that there's really no difference between men and women with their ability to get calls overturned, or the proportion of calls overturned. And so if we type that in, what do they want for the answer here? They want, yeah, so here's the right answers, and cool. So let's see, I'm going to hit, they include, does not appear to be significant difference. Yep, there's no difference. So I'm going to hit stop sharing here for a second. And Zach, what do you think? Is that what you're looking for?
Yeah, no, that helps. I don't know.
Cool.
Did you, when you were putting it into the calculator, did you put 99 or 98? Because I think I must have been putting the wrong confidence in there.
But it says right on there 98.9% confidence interval. So that's what I did. I just put 0.99. And that's pretty much what it's going to do. The ones that get a little tricky is if it's a one-tailed test, and then they just kind of say, now make the appropriate confidence interval. Okay, if it's 1% in one tail, that means it's 98%, because that'd be 1% in each tail, because it doubles that area. That's the only ones that get a little tricky. That will not be happening on the test. I will not be doing that to you. I just flat out say, make a 95% confidence interval and you're good. Is the p-value just what is written in that little chart? Yeah, yep. So it was 0.855 or whatever it was. Stella, are you able to loosen your microphone there? Okay, why don't you go ahead and use your telephone to call in like Bryn. Upper left-hand corner, there's a cell phone number you can use and you can call in to use your phone for audio. Cool? All right, Zach, what's up?
So when you also get your results and the chart on StatCrunch for the confidence interval, when would we use that standard error that is given to us and our upper and lower limits? Because I think I was trying to throw that in some of my calculations. I don't think I was necessarily supposed to.
Yeah, pretty much all you're going to be asked to do is put in the upper and lower limit. The standard error is how much left and right you go from the difference. So if let me put a whiteboard here. So for instance, if this is our test statistic right here, and this is our standard error, you just go that far left and that far right, and this gives you your interval. So this is like your standard error, positive, standard error, negative, and this is like your sample mean or sample proportion or sample difference, whatever that is. So pretty much all confidence intervals are this way. Here's my first initial guess, and now I open it up left and right based on how confident I want to be, and that's that calculation of the standard error. Let me go ahead and upload the formula sheet real quick here, and I'll kind of show that.
So is that equivalent to your margin of error?
Yeah, that is the margin. Yeah. So the margin of
Gotcha.
error is all this, and the standard error is your z multiplier or t multiplier times your standard error. So are there a few questions that are asking you to break it out that much?
No, when I was having troubles inputting the calculations, I was trying to do it the long way, and I was trying to use
Oh,
that standard error number to try to get my confidence intervals.
yeah. So you don't need to. So this is, if you look, can you guys see this formula sheet?
I can see it.
Yeah. So right here, this is like your standard error, the blue, and then the like orange I'll make is your margin of error.
Gotcha. That makes
So
sense.
yeah. So and then so in this one, this is the one we just did for difference of two proportions. That's the whole formula for that one. So on your test, what I write on there is if you just write down the correct formula, if for some reason you got it wrong, I'm still going to give you partial credit. You got it right, you got it right. But there is some benefit at least knowing like where are these numbers, what are these numbers doing, and what calculation and all that stuff. So usually what happens, ideally, if you've got enough time, you do at least one or two this way, and then you stack crunch in the rest, so you get a feel for what's going on here. But since it's 12 hours and 36 minutes till everything's due, and you'll have to make that determination how much time you can put in. But if you're already on section 9.1, you've done this a lot already, so that's great. All right. Let's see here. And then here's the, so if you can see here, this is for hypothesis testing, the denominator is like your standard error. Your standard error. And there's pooled and unpooled. Don't get too worked up about that. Standard error right there, standard error right there. So really it's the difference between the sample and the population divided by the standard error, and that's how far away those results are from each other. And then you get your various, this is next week is chi-squared. So that's, I think you're actually doing this one, yeah. So most of this formula sheet is this week, and most of your test is going to be over this stuff next week. So you've got obviously a whole week to kind of review it all, practice test, all that good stuff. Standard error on StatCrunch, I believe it just gives it to you. Yep, it's right in the printout. Here, I'll share my screen. I don't know why you would need to have the explicit standard error given to you, but if you need it, it's right on the table. If you need the margin of error, you're going to have to find the difference between the top and the bottom and then divide it by 2. Let me share this. I think that's it. Stella, did you get your phone working? Oh, you can't talk. Okay, no worries. Standard error is, let me share my screen. All right, can you see that? And there's a standard error right there. And there's but if you need to find the margin of error, you'd have to take the difference between these two and divide it by 2, because that'd be the margin, because you go that much above and that much below. So you just take the difference here, which is going to be about 0.1. So the margin of error is about 0.05, looks like.
And real quick,
Is that it? Yeah.
Yeah. So if you find the difference of that and divide it by 2, that gives you margin of error. And if finding confidence intervals, you just do p hat or p1 minus p2 times that margin of error.
Yes. Yep.
Or not.
Minus,
plus and minus.
subtracting. Yeah. Yep. So you find, if you're finding difference between two proportions, find the difference and then you plus or minus the margin of error. Yep.
Right. Okay.
Yep. Very good. The way I look at it is visualize it like I've got a bag that I'm going to try to capture the true population proportion or mean or difference or whatever it is. So I get it. Where do I start the bag? Well, it's the difference in the samples or the sample mean or the sample proportion. And then I open the bag up. That's the margin of error left and the margin of error right. And we're 95 or 99% confident the true proportion is somewhere in there, or the true mean or the true difference or whatever it is you're looking for. It's like casting a net. How big of a net do I need to cast to capture what's really going on here? And I can never be certain. That's why we can always say we're 95% confident or 99% confident. To be 100% confident is infinite. So, or like if it's proportion 0 and 100%, you're not really saying anything.
All right, that answers all my questions. So I'm going to go ahead and start working on that. But I thank you for your help.
Oh, you bet. Stella asked a great question about the discussion. She's like, how do I find the confidence interval for part 7? So Stella, have you downloaded the sample, the aggregate data yet? Okay, so then you just find the proportion of Black and African Americans out of the total. That's your p hat, and then you just do a confidence interval for one proportion. And do you feel comfortable doing a confidence interval for one proportion with either StatCrunch or the formula, or would you like me to go through that? Yeah, I'll just show it on StatCrunch. So I won't do the exact one, but I'll just do one similar. Okay. Let's see here. Share screen. It's okay. So let's say your sample proportion. I'll just do it at proportions, one sample with summary. All right. So let's say it was 100 out of 400. Oops. I get down observations 400. So let's say 100 out of 400. 400. Cool. And make a 95% confidence interval and compute. There it is. So there would be your 95% confidence interval for the true proportion. Is that what you're looking for? Can you explain it again? Like, are you like this one right here? That's when you add the lower and upper and divide by 2. I don't, for your discussion, they don't I don't think you have to be explicit about the margin of error. I think they just want the confidence interval, which is given to you right there. Lower limit is left side and upper limit. So it would be 95% confident the true proportion of inmates that are Black or African American is between about 20.8% and 29.2%. I just made my numbers up, but you'll be able to count those from that sample data. It's close to this, I think. They put the formula there if you want to use it. It's just you're trying to find the 95% confidence interval, which comes from your formula sheet, which should be right here. So this is the very kind of the most basic one, the very first one right here. Your p hat is that sample proportion. Z is if it's 95%, you use 1.96. Sample proportion n is how many count there was. So this formula is really what StatCrunch is doing for you. And the plus and the minus is the margin. This is all your margin of error. So you find your starting point and go left and right the margin of error. Okay, cool. Good question. Let's see here. So Bryn, how about you? How's this going for you?
So far, well, for the discussion or the homework?
Whichever one.
The discussion, I was a little, so for the, what's it say? Is there disproportionate? Okay, so the percentage that I found was like 7.2. Let me find my.
About 7.2%-ish.
Yeah.
Yep, that's pretty typical when you Google the population proportion for Polk County. Yep.
Okay, and then
so
yeah. That's okay.
So
perfect. That
so the
works.
null hypothesis is p equals 0.072, right?
Oh, okay. I didn't know what I should do for that point.
Yep. So the null hypothesis. So think about it this way: if the exact same proportion of the population is being arrested, that would mean about 7.2% of all people in Polk County Jail would be Black and African American. True?
Yes.
Now, the
Okay.
alternative hypothesis is we think it's probably greater than that. All right, cool. Thanks for coming, Stella. And then so then you're going to use a one sample Z-test for proportion, use StatCrunch or the formula. You'll get a really big Z-score, which means you'll get a very small p-value. So there will be very strong evidence to reject, and that because it's typically about triple or quadruple the percentage of the actual population.
Okay. That's helpful because I was like, I don't know what to do. But I think I can figure it out from there, the rest of it.
Does that make sense? Like this is what our starting point should be?
Yeah, it does.
Yeah.
Because I was thinking it would be 72, and I was like, wait, that doesn't necessarily make sense because I did the numbers, and it was like way too much. I was like, whoa.
Yeah, so this is the great thing about statistics and inference. What can we really say? All we can really say is that there's a higher percentage than the population. That's all we can really say. And we can't go into causality. We're just doing an observation. We can't. Those are different questions to answer. This is the problem with statistics: is people will take a stat like that, but the stat in itself, all we can do with statistics is describe observations or experiments about populations. So we're observing this. Those are completely other questions of causality or why. Those are more complex questions, but it does gives us it's kind of like smoking. Do we see more cancer with smokers? Yes. Why? That's another question. we can, or in Iowa, maybe we have more higher rates of cancer. Great. Why? Well, is it because of nitrates in the water or not? I don't know. Are there other lurking variables? This is what makes research so hard, is trying to control variables and get it down to what is really the most prominent. There's usually multiple variables that go into most statistics. The problem is people want to say correlation or observation equals causational of things, and that's usually when they don't get statistical thinking. That's the problem. That's dangerous. Problem is
Yeah.
many people, especially people in leadership positions, seem to like not understand statistical thinking, and that gets very dangerous. Yeah, so this is why you're here. You're here to like critically think. Great, you have this data. Great, it says something, but what can we really say, and what are other questions that need to be answered, or what are we having some sampling error, or are there biases? Are there do we have enough data? Is it representative? What other questions can we even answer with observation, or what experiments can or can't we do? That's how complex this gets, but at least this is a good first dipping your toe in that direction.
For sure.
Cool. All right, does that help you with that discussion then?
Yeah, it does. It helps a lot.
Cool. Yeah, it doesn't take that long. I mean, just a lot of people are just daunted, like, oh my gosh, look at this, I have to do this. So it's like, no, just look at it. You're like, oh, I Google this, great. Oh, here's some sample data, right? So it just, it feels like the hardest thing is just to get started.
Yeah, that's for sure.
Yeah, but once you get started, you're like, oh, well, this is just like a homework problem, no big deal.
Yeah, that's how I feel.
Yeah,
Like,
so
oh,
same thing with online homework. Once you get started, you can start cruising, really,
yeah,
because it's the same thinking on every problem almost.
pretty much, yeah.
Yeah.
I thought whoever's homework was up, I thought that was a similar problem that I needed for homework.
Okay, good.
But it actually, so the one that was told, it's a 9-2, and it says
Okay.
for me to construct an a confidence interval, but it doesn't say like 99% or anything helpful like that.
Yeah, so what alpha level did they give you?
0.01.
And is it a one-tailed or a two-tailed test for the hypothesis test?
One tail.
So that means that's the tricky one. If it's a one-tailed hypothesis test and they give you no direction on the confidence interval, you've got to assume 1% in each tail then. So make it a 98% confidence interval and you'll get it.
Okay.
That's a bogus question. I will not do that to you in a test. I hate that. I understand it makes you, because does that make you think next level about the question? Kind of, right? So if I'm looking at 1% in the tail, here, I'll draw a picture of that. Hold on. Let me put this on the screen. All right, let me erase this. How do I clear this? There we go, clear. Okay, so if I've got this little distribution, right? And here's if I'm looking for 1% out here, now if I want to make a confidence interval that is exactly the same cutoff point, right? How much does it have to be in the left tail then?
Also 0.01.
Very good. And so what's in the middle? 98%. That's a 98% confidence interval. How's that?
No, that makes sense. Now I get that.
Yeah, that's tricky. If it was a two-tailed test and it was 0.01, it'd just be a 99% confidence interval. But if it's a one-tailed test, then you've got to do this trickery to convert it to make it the same cutoff. Like I said on the test, I will explicitly just say, make a 95% confidence interval, go. Like it did on that other one. Yeah. So that's a little tricky, and I wish they didn't do that.
And then my next question is with 9-3. It's like asking you to make a statistics test, or no, a test statistic, and then find the critical values.
Critical values are not a good method. I'm sorry, there's a couple homework questions that ask you to do it. There is a video on finding the critical values, and that's what's going to be with the T statistic. So if you go to, that's section 9.3, right?
Yes.
So if I go to section 9.3, and I click on, let's see here. Difference between two means on StatCrunch. Oh, 9.3, there it is. Okay. Let's see here. Paired sample t-test. Independent, dependent. You know what? I made, hold on. T critical. Let's see here. T critical value. I'm just Googling this because I made a video years ago on this.
Okay.
I'm gonna put Petrock if it comes up. Well, it used to be more popular, I guess, in StatCrunch or on YouTube, but who knows anymore. There's some really good ones on here. Actually, this looks like a good one, maybe. Of course, there's ads. And it shows how to do it with StatCrunch.
Okay. I can look that up.
So pretty much here, here's the way I do it. And I think this is a pretty easy way to do it. This is the easiest way I know to do it. So
Okay.
I'm going to go ahead and share the. Here we go. Here's the tables. This is actually one that I think is easier with a table than using StatCrunch.
I'm not sure if I see it.
Not yet. I'm
Do
just
I have to
about there.
click up? Oh, okay. Okay.
How about that? There we go.
Oh, perfect.
So, do you know how many degrees of freedom there are in this problem? Like, what's your sample size?
Would it be 1,000? Be the sample size?
Yeah, I don't know. It
Oh
should
wait,
say
that's
in the
1,000. Okay, that's the difference of freedom.
degrees of freedom. Yeah, that's n minus 1. Your sample size minus 1. So, does it give you a sample size on that one?
Not that I can see.
All right. Once you hit ask my instructor on that one, so I can see it.
Okay.
You know how to do that?
I was just double checking to see if there was one.
It'll be good for me to see it anyway, just in case there's some other weird stuff going on.
Okay.
Yeah, just go ahead and hit that button, and it'll shoot it to me.
I
There it
just
is.
sent it to you.
Yep, I got it. All right. So, it says click on the icon to view the reaction time data. And then I can actually load this data in StatCrunch. Very good. So it looks like there's, this is paired data, 1, 2, 3, 4, 5. So it'd be 4 degrees of freedom.
Okay.
Oh,
I was looking directly at this thing. That.
Yeah, so there's 4 degrees of freedom.
1,000, but...
It's a two-tailed test of 0.05. So if I go to this, so I'll use my pointer. See that row 4 degrees of freedom?
Mm-hmm.
And if you look here, if you want 95%, it's this middle column, which gives you 2.5% in each tail. So there would be your T critical values, plus and minus 2.776.
Okay.
If you use the T calculator, you can do the same thing, but you'd have to know, how much to put in each tail, 4 degrees of freedom, type all that in, and you get the same number. So that should be the right answer, 2.776 for your T critical value.
It said that it was 1 point. Oh wait, that's the test of statistics. Okay.
I typed it in and it said okay. It was correct. 2.776.
Oh, perfect. I did too.
Yep. So it looks like in this case your test stat was 1.675, so it's not big enough Again, this is a bad way to do hypothesis testing. It should be using a p-value method. So that makes it less dependent on all these other things we're looking at. If I had to see a p-value of 0.4, I'd be like, oh, that's not statistically significant. There's not enough evidence to reject the claim. Boom, move on. It doesn't even matter what test I'm using. P-value could be using, there's many statistical tests. The p-value kind of gives you the probability of that thing happening, and you don't even per se have to know that much about what test is being done. It just says, based on the correct test, based on these results, here's the probability of that happening by random chance, and you can just interpret the p-value and not worry about looking up stupid critical values all the time, which is why the rest of the world has moved away from this homework. This author and this content still hasn't done that.
Gotcha.
But
okay.
Cool.
Now that helped a lot. Yes.
Good.
I'll double check if there's anything else, but I'm pretty sure.
You guys are asking. These are great questions. These are exactly the ones that you should be asking.
Okay, perfect. And then, oh wait, I know how to do that.
And the last section is like on paired data, and a lot of people have a question on that. Highly recommend oh yeah, that is the section. Yeah, it's right there. Paired sample, t-stat, and StatCrunch. That will show you how to do that problem. Yeah, it's right there on Blackboard.
Okay.
Under section 9.3. Yep. It's a 2-minute 49-second video. That is well worth the 2 minutes and 49 seconds.
Okay. Perfect.
Yep.
I can do that. Okay.
If you've got all of your online homework done by tonight and your discussion, first of all, whoever does that is a rock star, and that's really good. That means you put on serious time and effort this last week and on top of stuff. I've got lots of A students in this class, which is very fun. So good job if you're able to get all that done. Next, this is the hardest week. Next week will not be that hard. You'll breeze through the stuff on chi-squared if you've done this stuff. And you'll have plenty of time to do many practice exams and watch videos over. I've got, I don't know, 5 old exams sitting out there with solutions. So you will be well prepared to take the exam. Like, honestly, if I was you, if I'm done with this stuff by tonight and I'm already in the groove, if I was you, I would knock out the stuff on deviations on Wednesday and Thursday and review on Friday and take the test on Friday and go enjoy your 4th of July weekend and not have to worry about getting that done on Tuesday because you're probably taking the 5th off anyway. So
yeah,
that's what I would do.
That's a good idea. I didn't even think of that.
Yeah, I would get after it. Just keep, if you're already in this group, because you're already working, don't take tomorrow off. Just keep going.
I won't.
Well, most students will. You know, like I sent that message out last week. I'm like, hey everybody, I noticed a lot of you haven't started working. It's Friday. Unfortunately, this is extremely normal that you took Wednesday, Thursday, and Friday off, and now you're going to take Saturday and Sunday off. And now you're going to start working on Monday or Tuesday, and oh my gosh, I have 12 to 15 hours of work, and I'm not going to do well.
Yeah,
Unfortunately,
this is a lot of stuff.
Yes, I couldn't express it enough in my messages. You really need to get after the stuff. But if you get this, you're going to do very well in the test. You can do very well on your project, and this is the meat of the course if you get what's going on here.
Yes, perfect. I like the sound of that.
Yes, and then chapters 10, 11, much easier. Linear regression, some goodness of fit. And then the big thing is after you get done with this test, you get to work on your project the last few weeks. And that's of your own choosing, and you'll have time for feedback on that, and you'll have a discussion, posting your ideas so everybody can give you, hey, that's a great idea, or what do you think about this, or where are you going to get your data from, and what kind of question is it? And that's going to be essentially your final exam grade this summer. is going to be your final project.
So is this the next exam, our last one?
Yes. Yep.
Okay. Gotcha.
That's it. So that's a week from today. That'll be due. But like if I was you, I would, if you feel comfortable and you're like, yep, I'm getting this. This makes sense. Go through several practice exams. This is awesome. If you want to do another, hold on, I'm getting a phone call. In case it's a student. Hello, this is Dan. It's a telemarketer, so we don't have to worry about that.
Oh.
But yeah, if you're feeling comfortable, if you want to do like even another review later this week to review for the test, let me know.
Okay.
And I'm assuming we'll have some people wanting some office hours next Tuesday. So I mean, you don't have to get it done, but that if you don't, you know, whatever you want to do for the weekend. But if it was me,
Yeah.
I would be like, I'm going to keep going, and if I feel really good about this, I'm going to knock that test out before the 4th of July weekend. Otherwise, if I don't, no big deal. You can still chip away at it. Have all day Tuesday to do some more review. Got the whole night to knock that thing out.
Perfect. Is chapter 6 also on the exam?
No.
Okay.
Nope. Just 7 through 9.
I don't have that finished yet. Okay.
Nope. And you can. That's due by the end of the course. And
I saw that.
after doing this stuff, it'll be a piece of cake.
Sweet. Awesome. All right. I don't think I have any more questions, but I appreciate you meeting up with me.
Yeah, anytime. This is really helpful to everybody, honestly. And I'm gonna post this video of the office hour probably on YouTube. And just put the link in, because it's just easier to access from email. If people only click on it in their email because I send an announcement out, it'll work either way. So I'll probably put this out there for everybody to watch.
Okay, sounds good.
Okay,
Awesome.
Thanks, Bryn, for getting this going and asking the right questions.
Yeah, of course.
Excellent.
Thank you.
All right, we'll talk to you later.
Sounds good. Bye.